Hello my dear friends. Now in this session we will take up a topic called height and distance. It's a part of trigonometry, or it can be taken as a standalone topic also. Now the very first thing that we need to understand is the angle of elevation and the angle of depression. Right? Now in this there is one very important thing that we need to understand. The first thing is, how do we look at things? Right? So for example, a normal person has an eye level like this. So when a person sees with his eyes, he sees straight, right? This line is called horizontal line. Okay. So anything that you see, it is with respect to the horizontal line. Suppose there is an object here like this. If you want to see it, so you will roll up your eyes. So by whatever angle you roll up, this angle is called angle of elevation. All right. This theta is angle of elevation in this case. Okay. Similarly, if there is an object at the ground and your eye level is this, okay, so you usually see in a horizontal line. To look down, what will you do? You will roll down your eyes, right? So here it was rolling up, here it is rolling down. So by whatever angle you roll down, like in this case, suppose this angle is alpha, then this angle of depression is alpha. So in any case, the angle, whether it is angle of elevation or angle of depression, it has to be measured with always with the horizontal line. So whether you look up or you look down, just measure what is the angle that you move with respect to horizontal line. If you go up, if you look up, or if you roll up, all right. So if you roll up your eyes, there will be an angle of elevation. And if you look down, okay, and if you look down or you roll down, that means the angle formed with the horizontal line will be the angle of depression. Okay, so this is the very basic thing about angle of elevation and angle of depression. Okay. Now there is some application of trigonometric ratios in questions of height and distance. All right. So what we'll do is we'll take some basic ratios of trigonometry, that is sine, cos and tan, and we'll describe them in a right angle triangle. Okay. Let's say there is a right angle triangle like this. Let's say this is AB, this is C, right? This angle is 90 degree. So let's consider one angle, let's say alpha angle, right? Or this is C angle. Look at this alpha. For this alpha, sine of alpha is defined as the opposite side. Okay, so opposite side divided by hypotenuse. We all have done this in 9th and 10th standard. Here I'll just take a revision of that. So opposite side to alpha, in this case it is AB, and the hypotenuse is AC. Similarly, cos of alpha. Now cos of alpha is adjacent side, the side beside the angle, divide by hypotenuse. Right. So in this case, if you look at alpha angle, for that the side besides alpha is BC, or the adjacent side is BC, divide by hypotenuse is AC. And the most important one is tan angle, tan of the angle. So let's say tan alpha in this case is equal to, or always it is equal to opposite side divide by adjacent side. In this case, the opposite side is AB and adjacent side is BC, right? This is the most important one. Okay. So for this angle alpha, tan of alpha will be AB divided by BC, AB divided by BC. All right. Let's take one more thing. If suppose we also consider this angle beta, look at this angle beta, angle A is angle beta. For beta, if you take tan value, what will happen? Tan beta will be equal to, now the definition is the same, opposite upon adjacent. Okay, opposite upon adjacent. So what will it be equal to? Tan of beta will be, now for beta, opposite side is BC. So it is BC, divide by adjacent side is AB. So it is AB. So BC by AB, that is the value of tan of beta. Right? So we have defined tan alpha, we have defined tan beta. We have also defined sine alpha and cos alpha. You know, just for the sake of completion, let's also take up sine beta and cos beta. Right? Now what will be sine beta? Sine beta will be opposite side, that is BC, divide by hypotenuse. Sine is opposite upon hypotenuse. So it is BC divided by AC. Similarly, cos of beta is adjacent divided by hypotenuse. So adjacent is AB, divided by hypotenuse is AC. Alright. So this is the basic revision of all the trigonometric ratios in terms of a right angle triangle. Primarily a right angle triangle. Okay. Now we will try to recall some specific values of trigonometric ratios for some special angles like 30 degree, 45 degree and 60 degree. Okay. And we have to memorize, we have to use all these values frequently. So let me write it. Sine 30 degree. How much is sine 30 degree? You can use it as 1 by 2. Similarly, cos 30 degree. Cos 30 degree, you can directly use it as root 3 by 2. And there is another relation that we must know. Tan alpha is equal to sine alpha upon cos alpha. We all know that, in fact, right? So from there you can see that tan 30 degree will be equal to sine 30 degree divided by cos 30 degree. So 1 by 2 divided by root 3 by 2. So 2 and 2 will get cancelled and we will have 1 by root 3. Right? Or you can directly, you have to actually memorize sine 30 degree 1 by root 3 directly. The tan value you must remember in any case. Let's say for 45 degree. Sine 45 degree is equal to cos 45 degree and both are equal to 1 by root 2. And tan 45 degree will be equal to sine 45 divided by cos 45 and both are equal, so the ratio will be 1. Right? So tan of 45 degree, this is equal to 1. And for 60 degree, sine 60 degree is equal to root 3 by 2. Cos 60 degree is equal to 1 by 2. And tan 60 degree will be, you can divide sine 60 by cos 60. So root 3 by 2 by 1 by 2. 2 and 2 will get cancelled and we will have just root 3. Right? So focus on the values of tan. Tan 30 degree 1 by root 3. Tan 45 degree 1. And tan 60 degree root 3. Okay. So these are the most important values which will be directly used in the questions of height and distances. Before going to questions, there are some special triangles. We'll just try to recall them. The first one of them is a right angle triangle in which the angles are 30 degree, 60 degree and 90 degree. Right? If the sides are, let's say A, B, C, the smallest side is A, which is opposite 30. The next side is B, which is opposite 60. And the largest is hypotenuse C, that is opposite 90 degree. In this case, the ratio of ABC is directly given as 1 is to root 3 is to 2. Alright. So you can directly memorize it. In the triangle having angles 30 degree, 60 degree, 90 degree, the ratio of sides is 1 is to root 3 is to 2. 1 being the side opposite 30 degree. Right? Root 3 being the side opposite 60 degree and 2 being the side opposite 90 degree. Alright. Let's say if I draw the triangle like this, say this angle is 30 degree, this is 60 degree and this is 90 degree. Then what will happen? The ratio will change. Opposite 30 has to be taken as 1. Opposite 60 has to be taken as root 3 and opposite 90 has to be taken as 2. Okay. What is important is the relation of the two perpendicular sides. Right? Opposite 30, 1 and opposite 60 it is root 3. Okay. We can directly use this ratio of sides. Alright. Now let's take another one. The second one is the more popular and more well known. Alright. This is again a right angle triangle in which two sides are equal. Now if two sides are equal, that means the angles will become 45, 45. Okay. So if the two angles are equal, that means these two sides should be equal. And their values can be taken as 1 and 1. And the third side can be taken as root 2. So here the side ratio will be 1 is to 1 is to root 2. You can simply memorize if the angles are 45 degree and 90 degree, then the sides ratio will be 1 is to 1 is to root 2. Right. 1 and 1 will be opposite 45 degree. Okay. And there is one very specific triangle that is 30, 30, 120 degree. In that case also you can memorize if this angle is 120 degree and these two sides are equal. Here these two sides were equal. So these two sides are equal. Then these angles will be 30 degree and 30 degree. Right. From there you can see that the sides opposite 30 can be taken as 1 and 1 and side opposite 120 can be taken as root 3. So the side ratio will be 1 is to 1 is to root 3. Right. Now other than them, there are some right angle triangle triplets. Right. They will also be useful. Right angle triplets. They are also called Pythagorean triplets. So if you remember them, it will be really helpful. Alright. Pythagorean triplets. Okay. So just to name a few, 3 is to 4 is to 5. So that means if the sides are in the ratio 3 is to 4 is to 5, they have to be in right angle triangle. Okay. Let's say the ratio 5 is to 12 is to 13. Right. 8 is to 15 is to 17. Okay. Then we have 7 is to 24 is to 25. And one more, that is 20 is to 21 is to 29. Right. So these are some 4 or 5 Pythagorean triplets that also you can memorize. Now let's go to the questions and see how do we apply these things. Now let's take up the first question. It says a little boy is flying a kite. The string of the kite makes an angle of 30 degree with the ground. If the height of the kite is h equal to 24 meter, find the length of the string that the boy is used. Usually, I mean, all of us would have done this in our childhood. When you fly a kite, the string goes like this and you're standing on the ground. Okay, so this is the kite. All right, this is the height of the kite. This length is the height of the kite. Here it is given 24 meters. Okay, and it says the string of the kite makes angle 30 degree with the horizontal. This line is horizontal always. Okay, now this angle is 30 degree. This is the height and this is the string. Right, this diagonal length is the string. How do you find the length of string? Now there are two ways to do it. One is you can directly use the ratio of 30, 60, 90, or you can take it like this. Let's say we have to use this side h, that is vertical, and we have to find the length of hypotenuse. Okay, the string is the hypotenuse in a right angle triangle. Right, so what do? We have to use the opposite side and hypotenuse. If you remember, there is a relation sine theta is equal to opposite side divided by hypotenuse. Right, in this case the angle theta is 30 degree, so it is sine 30 degree is equal to opposite side is h divided by hypotenuse is string. All right, sine 30 degree is 1 by 2, h is given 24 meters divided by string. So we can find the length of string from here. Right, the length of string from here will be equal to 2 into 24, and that is equal to 48 meters. Right, so this is the answer of this question. So this was one direct question, and it was application of sine theta. Okay, now let's take up the next question. Now this question says a pole of a height h equal to 50 feet has a shadow of length L equal to 28.87 feet at a particular instant of time. Find the angle of elevation in degrees of the sun at this point in time. Now this is one very important concept. Let me name this as shadow concept. Say for example, the sun is shining here. Okay, this is the ground, and if you erect anything, let's say this is the object, what will happen? How will the shadow be formed? Look at this carefully. The sun ray starts from the sun, goes to the top of the object and touches the ground. Right, if this is the object, then this length, the length that I am grading, is the length of the shadow. All right, always remember that the ratio of object is to shadow length is always constant. At any particular instant, it is always equal to constant. And let's say if this angle is theta, then clearly, as you can make out, object upon shadow, object will be the side opposite to theta and shadow will be adjacent side. So this constant value will always be equal to tan theta. Right, and this angle theta is called angle of elevation of sun at that particular time. Okay, angle of elevation of sun at that time. Right, now what does it mean? There is a simple relation between the object length, shadow length, and the theta value in terms of tan theta. So if I know the object length, if I know the shadow length, I can find the angle. Like in this question, what does it say? It says there is a pole of height 50 feet. It has a shadow of length 28.87 feet. All right, let's take it smaller one. All right, this must be the line that has a ray of sunlight. All right, and this angle must be the angle of elevation of sun. Okay, so you have to just remember, this is the object, this is the shadow. This 28.87 is the shadow. What you have to do is just apply tan theta equal to object upon shadow, that is 50 divided by 28.87. All right, from here, whatever value of theta you get, that will be the answer. Now this is obviously going to be a tricky calculation. It is 50 divided by 28.87. Now we can do some approximation. Okay, we can take it as 28.9, or we can take it as 29. So it is 50 divided by 29. If you simplify, it will come out to be 1.72 approximately. Now here we have done slight approximation, that is why we are getting this value. This is very close to actually 1.732, which is root 3, and root 3 is equal to tan 60 degree. All right, now what does it mean? It means in this case theta is very close to 60 degree. Obviously if options were there, you could have checked from the options also, but here we are saying that it is approximately equal to 60 degree. Don't worry, you have to find the answer in approximation only. Okay, in the exam, when you get a question, you will always get some options, so it will be easier from there to check. So in any case, we are getting here 1.72 around. right? Which is very clearly, it is very close to 1.732. So the nearest simple value will be tan 60 degree, and that is theta is equal to 60 degree. So in this case, the angle of elevation of the sun is 60 degree, and that's our answer. Okay, now let's go to the next question. It's a direct question again. It says the angle of elevation of the sun is 60 degree. So the sun ray will be with the ground at length or at an angle 60 degree. The length of the shadow of a man who is 180 centimeter tall. So suppose this is the man. So man height is 180 centimeter. This is the man or object, right? Then clearly this shaded thing has to be the shadow. All right. And this angle is 60 degree already given. So we can say tan 60 degree is equal to the object, that is 180 centimeter, divided by the shadow. Now what is the question saying? Find the length of shadow. So from here we can calculate shadow is equal to, now tan 60 degree is equal to root 3. So shadow length will be equal to 180 divided by root 3. Now you have to simplify it. So do one thing. 180 can be written as 60 into 3 divided by root 3. And 3 itself can be written as root 3 into root 3. So 1 root 3 will get cancelled, and we will have simply 60 root 3 centimeter. So if the option is given as 60 root 3 meters, write it like this only, right? So here is your answer. But if suppose the question is asking the answer in decimals, so then you have to take root 3 as 1.732 and you have to multiply. You have to memorize that root 3 is equal to 1.732. Root 2 is equal to 1.414. So these two square root values you should directly remember. Okay, so if you open it, you will get 103.92 centimeter. Right. So this is the length of shadow in this question. Let's take up the next question. This is another interesting question. It says 12-meter long ladder leans with a wall. So let's say this is the wall. There must be a ground on which the wall is erected, and there is a ladder. Ladder will always lean like this, right? So this is our ladder. This is the wall. Now at an angle of 30 degree with the wall, right? So this angle 30 degrees with the wall. So ladder with wall, that means this angle is 30 degree, right? This is where a lot of people make mistake. You have to read the question very carefully. It says very clearly 30 degree with the wall. So this angle is 30 degree. Now the wall is always at 90 degree. One angle is 30 degrees. So that means this angle has to be 60 degrees. The third angle has to be 60 degree. Now the question says find the distance of foot of ladder. This is the foot of ladder, right? From the wall, that means this length, suppose this length is x. Also find the at what height of the wall does the ladder touch. Suppose this is the height h. All right. Now ladder length is given 12 meters. Now look at this right angle triangle. In this right angle triangle, hypotenuse is already given 12 meter. This is the hypotenuse, right? Now you can use either 30 degree or 60 degree, or you can directly use the ratio of sides also, right? So first I'll take up the ratio of sides. Opposite 30 it has to be 1, opposite 60 it has to be root 3, and opposite 90, that is hypotenuse, has to be 2. Now 2 is given as 12, so 1 will be equal to 6 meter and root 3 will be equal to 6 root 3 meter. So straight away this distance of foot of the ladder from the wall is 6 meters, and the height of the wall at which the ladder touches is 6 root 3 meter. That is one way of doing this. Okay, that is the direct method, by the ratio of 1 is to root 3 is to 2. Why? Because 30, 60, 90, the ratio of sides is this much only. 1 is to root 3 is to 2. Alright, 1 being opposite 30, root 3 being opposite 60, and 2 being opposite 90, that is hypotenuse. Or what we can also do is we can use sine and cos. Okay, so let's say if I use sine 60 degree. Now 60 degree is this angle, opposite 60 it is height h, and hypotenuse is 12. We also know that sine 60 is root 3 by 2 is equal to h by 12. Now 2 cancels 12 6 times and 6 into root 3. So from here we get h is equal to 6 root 3 meters. If it is necessary, you can put the value of root 3 as 1.732. Alright, so if you do that, it will be 6 into 1.732, and that will be equal to 10.392. Alright. Now this x is involved in the adjacent side. This x is the adjacent side to 60. So let's use cos. So cos 60 degree in this case will be equal to x, that is adjacent side, divided by hypotenuse, that is 12. And we know that cos 60 degree is 1 by 2. So that is equal to x by 12. So 2 cancels 12 6 times. So from here we get x equal to 6 meter. But here, if you remember this ratio 1 is to root 3 is to 2, we had already done it a long time ago. Okay. Now let's take up the next question. This is a very interesting question. A tree cracks at a height of 20 meters from ground. All right, let's say suppose this was the tree, this is the original height. From the ground at 20 meters, suppose this length is 20 meters. This part of tree cracks and bends. So whatever was this length comes here now. So suppose this was x, this is also x, right? The tree has bent. Okay. So in such a manner that the top of the tree touches the ground at an angle 30 degrees. So this point was the top, then this should come here. Okay. So this point is that top, which was earlier, it was the top, right? And it touches the ground at an angle 30 degree, right? So here this angle is 30 degree. Now this is 30, this is anyways 90 degrees. So this has to be 60 degree. Angles are 30, 60, 90. So ratio of the sides can be taken as 1 is to root 3 is to 2. Now in this case, 1 is corresponding to 20. So root 3 will be corresponding to 20 root 3 meters straight away. All right. And this x will be 2 times 20. So it is 40 meter. Right. Now what was the tree length? The tree length was 20 meter on the bottom and x which was bent. X we have calculated as 40 meter here. So it is 20 meter plus 40 meter which is equal to 60 meter. Please try and see that you can use the ratio 1 is to root 3 is to 2. Right. Again and again we are trying to say that 1 is opposite 30 degree. Root 3 is opposite 60 degree. And 2 is the hypotenuse. Right. So it's very easy to memorize actually. So here we had the side given opposite to 30. So this was 1 corresponding to 20 meter. So root 3 will be 20 root 3 meter. So this 2, if 1 is 20, then 2 will be 40 meter. Right. So this was the bent part of the tree. This was the original remaining part of the tree. So the total tree must be equal to 20 meter plus x, that is 40 meter, which is 60 meter. Okay. So answer of this question is 60 meter. Now the question is also asking, also find at what distance on ground does the top of the tree touch, that is x, which is 20 root 3 meter. Right. So this distance from on the ground is 20 root 3 meter and the tree length is 60 meter. All right. Now let's take up the next question. Now this question says, what is the distance between a tower and an observer if the angle of elevation from the observer's eye to the top of the tower is 30 degree? The observer is 1.5 meter tall. All right. So let's the ground. So first let's try and understand the question. This is the observer. Let's say this is the observer and he's watching from his eyes. He always has to see horizontal, right? So his line of eyesight will always be horizontal. And suppose there is a tower, right? When he looks at the top of the tower, this person looks at the top of the tower. So this is the line of eyesight to see the top of the tower. And this will be the angle of elevation. Always remember, angle of elevation or depression has to be measured from horizontal line only, from the line of eyesight. Line of eyesight is always horizontal. All right. So this angle is 30 degree. Okay. Now this person is 1.5 meter tall. All right. And this total height of the tower is given 50 meter. So this is 50 meter. Now look at this. This situation is a rectangle. So if this length is 1.5 meter, this length should also be 1.5 meter. Okay. So what will be the remaining length? The remaining length will be 48.5 meter. The remaining upper part of the tower will be 48.5 meter, right? Now look at this triangle. This is 30 degree. Let's say this length is x or x. These two will also be equal. Okay. Now look at this triangle here, this triangle. In this triangle, if you apply tan 30 degree, it will be equal to 48.5. Opposite side to 30 degree is 48.5 divided by x. Now tan 30 degree is 1 by root 3. So 1 by root 3 equal to 48.5 by x. From here, if you multiply crosswise, you will get x equal to 48.5 root 3 meter. Right? Here, I will not put the value of root 3. You can do it on your own. Right? One thing that I can do is 48.5 can be written as 97 by 2. So let me say x is equal to 97 root 3 by 2 meter. All right. So this horizontal length is 97 root 3 by 2 meter. Now what is the question asking? The distance between the tower and observer. This is what we have to find. Right. So this is our answer of the question. All right. See, it is important in height and distance to draw the diagram properly. All right. And identify the type of triangle, or if we can use any ratio, or if we can, how we can use tan theta. Right. That is what is very, very important. Okay, now let's go to the next question. Now this question says two boats are spotted on the two sides of a lighthouse. If the angle of depression made by both the boats from top of the lighthouse is 30 degree and 45 degree. So let's say this is the surface, this is the lighthouse. This is one boat, this is the other boat, right? There are two different sides of the lighthouse. Okay, now one side, so okay, first of all, this is the topmost point, this is the horizontal line. Why horizontal line? Because there is an angle of depression from this point. Okay, so this angle is, let's say, 30 degree, and this angle, let's say it is 45 degree. Okay, please understand the angle of, here we have to measure angle of depression looking down, right? So it has to be measured with the horizontal line. Okay, now we know that this total angle has to be 90. So if this angle is 30, then this angle will be 60 degree. This is anyways 90 degree. So this angle has to be 30 degree. Or you could have directly taken this as, see, this is a horizontal line, right? This dotted line is a horizontal line. Okay, and the ground is always horizontal. All right. So we can directly take these two angles as the alternate angle. So if this is 30 degree, this is 30 degree. Similarly, if this is 45 degree, this is also 45 degree. Or what you can do, you can always calculate this total is 90, this is 45, so this angle has to be 45 degree, and hence this will also be 45 degree. All right. Now let's take the height of the lighthouse, that is given as 125 meter. So height of the lighthouse is 125 meter. Now let's give the names of the triangles. Suppose this triangle is triangle number 1 and this triangle is triangle number 2. All right. Now look at triangle number 1. In the triangle number 1, we can take this 30 degree angle and we can say tan 30 degree is equal to height h divided by, let's say this length is x, this length is y. So it is h divided by x. Now tan 30 degree is 1 by root 3. H is 125. Though we do not need the value of, oh yes, we need. So 125 meter divided by x. So from here we get x equal to 125 root 3 meters. All right. You can put the value of root 3 on your own and you can calculate. Okay. Now the second one, look at the triangle 2. In the triangle 2, look at this angle 45 degree. So if it is 45, 45, that means directly these two sides must be equal. Okay. So if this is 125 meter, y is also 125 meter. Or let me write it, tan 45 degree is equal to h divided by y. Tan 45 is 1. You must remember that. H is 125 meter divided by y. So from here we get y equal to 125 meter. Okay. So we have x 125 root 3 meter, y 125 meter. What is the question asking? The distance between the two boats. Look at the distance between the two boats. It is the total of x and y, right? So we say that distance between the boats is equal to x plus y. So if you add, x is 125 root 3, y is 125. So 125 root 3 plus 125, which is equal to 125 into root 3 plus 1 meters. All right. So this is the answer of this question. Okay. Now let's go to the next question. It says a ship is approaching an observation tower. If the time taken by the ship to change the angle of elevation from 30 degree to 45 degree is 10 minutes, then find the time the ship will take to cover the remaining distance and reach the observation tower, assuming the ship to be traveling at a uniform speed. First, let's draw the diagram. This is the tower. This is the first position of the boat. This is the second position of the boat. All right. And the angle of elevation changes from 30 to 45, right? So the first situation, angle of elevation would be this angle. This is 30 degree. And in the second situation, angle of elevation would be this angle, and that is 45 degree. Right? Now let's say if I have this total length as h, this length, only this length as x and this length as y, what will happen? Look at this carefully. For this smaller triangle, look at this small triangle. In the small triangle, tan 45 degree is equal to h divided by x. Now tan 45 is equal to 1, so it is 1 equal to h by x. So from here we have h is equal to x, or x is equal to h. Now similarly, look at the larger triangle, this whole thing, right? The large triangle, okay? Large triangle. Look at the larger triangle. In the larger triangle, this angle is 30 degree. For opposite 30 degree, the side is h and the base is x plus y. So we say that tan 30 degree will be equal to h divided by x plus y. Now h tan 30 degree is 1 by root 3. So it is 1 by root 3 equal to h divided by x plus y. Alright. So x plus y is equal to h root 3. Okay. We already have here x is equal to h. Right. So we can say that y is equal to h root 3 minus x, that is h root 3 minus h, which is h common root 3 minus 1. Alright. Now the question is saying that the time taken to go from 30 degree to 45 degree, that means from this point to this point, let's say this point is P and Q. So time taken to go from P to Q is 10 minutes. The question is saying that how much time will it take for the remaining distance, that means for x. So for y, the time taken is 10 minutes. Now y distance we have calculated as h root 3 minus 1. Alright, so what we can do is we can calculate the speed. So first let's calculate the speed. How would you calculate speed? Speed is, we know it is distance divided by time for that particular distance. Now here if I take the distance as y, then time taken will be 10. I'm taking the unit of time as 10 minutes only. Alright, we have the value of y, we'll use it later on. Now time taken to cross the distance, remaining distance x, will be the distance x, the same formula, speed equal to distance by time. So from here time will be distance by speed. Alright, distance by speed. Now distance is, in this case, it is x divided by, the speed is y by 10. So it is y divided by 10. So the required time, I will write here, it is the time required to cover the distance x is equal to, this 10 goes to the numerator, so it becomes 10x upon y. So it is 10 into. Now the value of x we have calculated as h, and the value of y we have calculated as h into root 3 minus 1. So h and h is cancelled and answer will be 10 upon root 3 minus 1, and this answer will be in minutes because this 10 was in minute. Let's simplify this, let's rationalize this. Multiply by root 3 plus 1 in numerator and denominator. Alright, so in numerator we will have 10 into root 3 plus 1. Now root 3 is 1.732 plus 1, so it is 2.732. So it is 10 into 2.732 divided by root 3 minus 1 into root 3 plus 1. You know the formula, this will become root 3 square minus 1 square, which is 3 minus 1. 3 minus 1 is 2, so it is 2. Now 2 cancels 2.732, 1.366. Alright. So if you just multiply this properly, this will be equal to 13.66 minutes. So the answer of this question is remaining distance will take 13.66 minutes. Alright. So here it is 13.66 minutes. Okay. So you have to be careful. The time given was for y distance. That is what it meant. And we have to find the time taken for x distance. Okay. So we just calculated x and y in terms of h. We use the unitary method to find the required time. Alright. So first we calculated the speed and then we had calculated the time for x distance. Okay. Now let's go to the next question. Now this is a tricky question. On the two sides of a road, there are two tall buildings exactly opposite to each other. The height of the taller building is 60 meters. Oh, so one of them is taller, one of them is smaller. If the angle of elevation from the top of the smaller building to the top of the taller one is 30 degree. So first let's draw the ground. This is the smaller one, this is the taller one. Alright. So from the top of the smaller one, let's say this is the horizontal line. This is the angle of elevation. So this angle is 30 degree. Right. This is, let's say, height h. And the height of the taller one is already given 60 meter. So this h will be equal to this length also. So this is h. So the upper part of this one will be equal to 60 minus h. Alright. Or look at the second part also. The angle of depression from the top of the taller building. Now this is the taller building. Right. This is the taller building. I am just thickening it. From this, let's say this is the horizontal line. Okay. This is the horizontal line. And from this point, angle of depression of the foot of the smaller one, that is this one here. Look at this. So if you join these two, this total angle is 60 degree, right? So as you can see, if this is 60 degree, then from alternate angle, because this horizontal line, this is a horizontal line. Okay. And this also is a horizontal line. So these two are parallel. Now if parallel lines are intersected by one line, then alternate angles are equal. So if this angle is 60 degree, then this angle will also be 60 degree. Or you can always calculate this total is 90. The upper part is 60, so the lower part will be 30. This is 90. So this angle will also be equal to 60 degree. All right. Now let me give some name. This is A, B, C, D and E. Try to be careful. Look at triangle ADE. Right. So I'm using the name so that you can find out where is A, where is D, where is E. Alright, so look at triangle ADE. In the triangle, this angle is 30 degree. So we can write tan 30 degree is equal to, the upper part is 60 minus h, divide by the base length. Let's assume the base length to be x. So this will be x, this will also be x. So it is upon x. Alright, so from here we get tan 30 degree is 1 by root 3. So it is equal to 60 minus h upon x. So we have x equal to 60 minus h into root 3. Let it be like this only. Now, look at the triangle BCD. Triangle BCD. In the triangle BCD, this angle is 60 degree. So we can write tan 60 degree. Now, side opposite to 60 degree is the total 60 meters. That is DC. So it is 60 meters. Divide by this x. We already have the value of x here. Alright, so from here put the value of x in this. So we will get 60 divided by 60 minus h into root 3. And we also have tan 60 degree equal to root 3. So root 3 is equal to 60 divided by 60 minus h into root 3. Alright, now let's do one thing. Let's cross multiply. So this root 3 into this 60 minus h root 3 will become, root 3 into root 3 will become 3. So this can be taken as root 3 into root 3 is 3 into 60 minus h is equal to 60. So 3 cancels 60 20 times. So we have 60 minus h equal to 20. 60 minus h equal to 20. So this tells us very clearly that h is equal to 60 minus 20, that is 40 meter. Okay. So the height of the smaller tower is 40 meter. Okay. So this smaller tower is 40 meter. This is what we have here in this question. And that is the answer of this question. All right. Now let's go to the next question. Alright, in this question it says Gaurav is standing on the bank of a river, observes that angle subtended by a tree on the opposite bank on him is 60 degree. When he goes 36 meters away from the bank, he finds that angle to be 30 degree. What is the width of the river? Right. Here we have to assume Gaurav as a point. We don't have to consider the length or height of Gaurav. Okay. So we take Gaurav as a point. Don't worry, these things will always be mentioned in the question. Right? So Gaurav is a point. Gaurav is to be treated as a point in this question. All right. If the height of Gaurav has to be considered, it will be given in the question. So nothing to worry as such. All right. Now let's say this is the width of the river. Let's say this is the point P where the Gaurav is standing. And suppose this is the tree. Let's say this is the height of the tree. Right. Now the angle subtended on him by the tree. So this is the total tree, and the angle subtended by the tree on Gaurav is 60 degree, right? And when he goes away 36 meter, right? So let's say this length is 36 meter. At that time, the angle is 30 degree, right? So again, this angle has to be 30 degree. Okay. So this angle is 30 degree, right? Now let's give some name again. If I say A, B, and this point is already P, this is C. Look at the triangle ABP. Alright. In that triangle ABP, if I take tan 60 degree, what will happen? Tan 60 degree will be equal to, opposite to 60 it is H, divide by beside 60, let's say it is X. So it is H by X. Now tan 60 degree is root 3. So root 3 is equal to H by X. So from here we get X equal to H by root 3 meters. Right. Now this X we have to find. Let's see how do we do that. X is the width of river. This X we have to find. We can find both H and X. Okay, let's see. Now the second part, look at the triangle ABC. Be careful. A, B and C. In the triangle ABC, this angle is 30 degree. So we can take tan 30 degree and that will be equal to, tan 30 degree will be equal to, the opposite side is AB, that is H, divide by this whole length which is X plus 36. Right. So if I have to only find the value of X, then from here only what we could have done, we could have taken H is equal to X root 3. Right. So if I take H equal to X root 3 and put it here, we will get X root 3 divided by X plus 36. And tan 30 degree is 1 by root 3. So we say it is 1 by root 3 is equal to X root 3 divided by X plus 36. Now if you cross multiply, you will get x plus 36 is equal to root 3 into root 3 is 3, so 3x. Okay, so if this x goes to the other side, we have 36 equal to 2x, so x is equal to 36 by 2, that is 18 meter. So the width of the river is 18 meter, right? If necessary, you can also find h. So first I'll write width of the river is x, that is 18 meter. And if you want to find the height, it will be h, that is x root 3. So it is 18 root 3 meters. All right. So these are the answers of this question. Now let's go to the next one. Now this question says two objects are situated on the same side of a building in the same line. All right. So let's say this is the building, this is the side, and there are two objects. Observed from the top of the building, their angles of depression are 45 degree and 60 degree. All right. So horizontal line, right? And with that, there is one object for which the angle of depression is 45 degree and one object for which the angle of depression is 60 degree. So the smaller one will be 45 degree and the larger one will be 60 degree. Right? So as you can see, this angle 45 degree and this angle will be equal because they're alternate angles. So this is also 45 degree. Similarly, if this is 60 degree, then this angle has to be 60 degree because they are alternate angles. All right. Let's give some names. So A, B, C, D. All right. Very clearly, let's see what is the question saying. It says find the distance between the objects. Now distance between the objects is C and D. So it is CD, that is what we have to find. All right. Now let's do one thing. The height of the building is given 150 meters. So let's say height is equal to 150 meter. Now look at triangle ABC. In the triangle ABC, we have tan 60 degree, that is equal to H divided by BC. Now tan 60 degree is root 3. So we have BC equal to H by root 3 meter. Let it be like this only. You could have taken X or Y also, but I'm just saying let it be H by root 3 meter. Now look at triangle ABD. Be careful, where is ABD located? ABD. In triangle ABD, this angle is 45 degree. So we can say tan 45 degree is equal to the side opposite to angle 45 is H divided by side adjacent to 45 is BD. All right. Now tan 45 degree is 1. So we can say it is equal to 1. So H is equal to BD or BD is equal to H. All right. Now we also have the value of H. Now H is given 150. So from here, BC is equal to H upon root 3, that is 150 upon root 3 meter. Now 150 can be written as 50 into 3 divided by root 3. And 3 itself is root 3 into root 3. So 1 root 3 will get cancelled and we will have 50 root 3 meters. So this was the length of BC. And BD is already H, which is equal to 150 meter itself. All right. So we have length of BD, we have length of BC. What is the question? CD? Look at this closely. The CD is actually equal to BD minus BC. All right. Now BD is 150 meters. Okay. BC is 50 root 3 meters. So if you take 50 common, it will give us 3 minus root 3. You can subtract. Root 3 is 1.732. So it is 50 into 3 minus 1.732, which is 50 into 1.268. All right. Which will be finally equal to 63.4 meter. Right. So the distance, required distance between the objects is 63.4 meters. Okay. Now let's go to the next question. Now this question said two objects are situated on the opposite sides of a building in the same line. All right. Observe from the top of the building, their angular depressions are 45 degree, 60 degree. All right. It's the same question, right? Find the distance between the objects. So now there is a ground, there is a tower, there is one point on one side and the other object on the other side, right? Again, same logic, horizontal line, angular depression of this one, angular depression on this one, right? The larger angle will be 60 degree. The smaller angle is 45 degree. The alternate angle for this 60, this one will be 60 degree. And for this 45, this one will be 45 degree, right? So if I take the triangles as A, B, C and D, now if you look at triangle ABC, look at this clearly, this triangle ABC, this height is given 150 meter. All right. And we have to still find CD. The only thing is this CD in this case is BC plus BD. You have to be careful about it. This is what we have to find. Now in the triangle ABC, tan 60 degree, all the calculations I think are going to be the same, right? So tan 60 degree will be equal to, you can see it is H upon BC. In the triangle ABC, tan 60 degree, opposite 60 it is H, divided by adjacent side, that is BC. Alright, now tan 60 degree is root 3. So we have root 3 equal to 150 divided by BC. So from here we get BC equal to 150 by root 3. 150 is 50 into 3 divided by root 3. So it is equal to 50 root 3 meters, as we had done in the earlier case also. And in the triangle ABD, you can see we can take this angle 45 degree and it will be tan 45 degree will be equal to the side opposite to 45, that is H, divided by the adjacent side, that is BD. Right? Now tan 45 degree is 1, H is 150 meter divided by BD. So from here we get BD equal to 150 meters. Right? So we already have BC equal to 50 root 3 meters and BD equal to 150 meters, and we have to find the distance between the objects, that is CD. So CD is equal to BC plus BD. Alright, now BC is equal to 50 root 3 meters, BD is equal to 150 meters. So just add them. Take 50 common, you will have root 3 from the first one and 3 from the second one. Put the value of root 3 as 1.732. So this will become 50 into 3 plus 1.732, that is 4.732. And if you multiply, you will get 236.6 meters. Alright. So the answer of this question, 236.6 meters, right? Now let's go to the next question. Now this question, it says the top of a tree makes an angle of elevation of 30 degree with the top of a pillar. Alright, so that means the tree is taller, okay, this is the tree, and the pillar is smaller than tree. So that from the top of the pillar, if you look at the top of the tree, there is an angle of elevation. This is the horizontal line, so this angle is elevation, and that is 30 degree from the top. And from the bottom of the pillar, if you see, again there is some angle of elevation only, and that angle has to be definitely higher, and it is 60 degree. Right? So look at the diagram very carefully. The tree is taller than pillar. That is what we have to understand. So this is pillar and this is tree. Alright. Height of the tree is 15 meter. Okay, so the total height is 15 meter. Find the height of the pillar. Let's say height of the pillar is H. Then from this rectangle, this is also H. Let's say the base length is X, the distance between them is X. So this bottom length here will also be X. Now let's give them some name, A, B, C, D, E. Alright. Look at the triangles very carefully. There is a right angle triangle AED. Right? In that triangle, look at this angle 30 degree. Okay. And for that matter, what is the length of AE? This total length was 15 meter. This lower length is H. So the upper length will be 15 minus H. Alright. Now, triangle AED. Triangle AED, we have tan 30 degree equal to, I'll write the names of the sides. Opposite 30, it is AE. And adjacent to 30, it is DE. Right. Now, tan 30 degree is 1 by root 3. I'm writing the names of the sides so that you can make it very clearly where is it located. Now, tan 30 is 1 by root 3. AE is 15 minus H. And DE is X. Okay. So from here you can see that we have to find H. So we can see that X is equal to 15 minus H into root 3. Let it be like this only. Now look at triangle ABC. ABC. In this, the angle is 60 degree. So we will take tan 60 degree equal to, I'll write the names of the side, that is AB, divide by BC. Now AB is 15, BC is X. And tan 60 is root 3. So root 3 is equal to 15 by X. So from here very clearly we can see that X is equal to 15 by root 3 meters. Right? And from here we have X is equal to 15 minus H root 3. So let's equate them. Equate these two values of X. So what will happen? We will get 15 minus H root 3 is equal to 15 by root 3, right? Now let's do one thing. Let's send this root 3 to the other side. So root 3 into root 3 will become 3. So it becomes 15 minus H is equal to 15 by 3. Now 15 by 3 is 5. So from here very clearly H is equal to 15 minus 5, that is 10 meters. So height of the pillar is 10 meters. Alright. So that is the answer of the question. Okay, now let's take up the next question. two temples opposite to each other are located on each bank of the river Ganga. So suppose this is the river, two temples are located, one is large, one is small. One temple is 54 meter height. We have to see which one. From the top of this temple, the angle of depression of the foot and the top of the other temple, right? So the 54 meter has to be the higher one, because we have to take angle of depression. Now you can take from a point, you can take angle of depression only when it is at higher place, right? So this is 54 meter. So from this top of this temple, if you look down, right? So if you look down, this is the horizontal line, and the angle of depression of the top and bottom is 60 degree and 30 degree. Oh, so angle of depression of the foot is 60 degree and angle of depression of the top is 30 degree. So this angle is 30 degree and this whole angle is 60 degree. All right. So first let's draw a horizontal line here also. Let's say this length is x. Let's say the smaller one is h. The question is find the height of the other temple and the breadth of the river, right? So x is the breadth of the river, right? And height is the smaller temple. Height h is the height of smaller temple, right? This example is exactly same as the previous question. So this is h. This length will become 54 minus h. And this length will become x. Right? Let's give some names. I'll take the same names A, B, C, D, and this point as E. Look at triangle AED. Now before that, let's do one thing. If this angle is 30 degree, then this angle will also be 30 degree because it is alternate angle. If this whole angle is 60 degree, these two lines are parallel. So this angle has to be 60 degree, right? So it's exactly the same calculation actually. So triangle AED will be, in that triangle we have tan 30 degree, and that is equal to AE upon ED. AE upon ED. Now tan 30 degree is 1 by root 3. AE is 54 minus h, ED is x. So from here we have x is equal to 54 minus h into root 3, right? And similarly from triangle ABC, if you look at this closely, we have tan 60 degree. In triangle ABC, this angle is 60 degree. So tan 60 degree is equal to AB upon BC. Tan 60 is root 3. So root 3 is equal to AB itself, that is 54, divided by BC is x. So from here we have x is equal to 54 divided by root 3. Alright, let it be like this only. Now here we have x equal to something, here we have x equal to something. So let's equate them. So from there we get 54 minus h into root 3 is equal to 54 upon root 3. So let's send this root 3 to the other side. Root 3 into root 3 will become 3. So we have 54 minus h equal to 54 by 3. Now 54 by 3 is 18. Okay. So from there we get 54 minus h equal to 18, and that gives us h equal to 54 minus 18, that is 36 meter. So h is equal to 36 meter. This is the height of the smaller temple. All right. And from there we can also, x is already here. We already have the value of x. X is the river width. So this is the smaller temple. Smaller temple height is 36 meter. And the river width is already equal to x, which is equal to 54 by root 3. You can take 54 as 18 into 3 and divide by root 3. 3 divided by root 3 will become root 3. So x is equal to 18 root 3 meters. So river width is 18 root 3 meters. Smaller temple is 36 meter. All right. So now let's take up the next question. Now this question says the angle of elevation of the top of two vertical towers as seen from the middle point of the line joining the foot of towers is 60 degree and 30 degree. The ratio of the heights of the towers is. Now this is a very interesting question, very important also. Suppose this is the width of the line joining the foots. Suppose this is the midpoint. So if this is the midpoint, we can say that this is length x and this is also length x. This length is x and this length is x because this is midpoint. Let's say it is m. Let's say this AB is one tower and CD is another tower. Join the midpoint with the top of both the towers. So what do we have here? We have these two triangles. All right. Now the angle of elevation from that midpoint, one of them is 60 degree, one of them 30 degree. So for the larger one, it will be 60 degree. For the smaller one, it will be 30 degree clearly. Now, let's assume that this height is, larger one is h1 and smaller one is h2. Alright. So we have to find h1 is to h2. This is what we have to find. This is the question asking. Alright. Now, let's do one thing. Look at the triangle CDM. In that triangle, this angle is 60 degrees. So straight away, tan 60 degree is equal to h1 upon x, opposite side upon adjacent side. Now tan 60 is root 3, so it is equal to h1 upon x. So x is equal to h1 upon root 3. Let it be like this only. Now similarly, look at the triangle ABM. In the triangle ABM, we have this angle as 30 degrees. So we have tan 30 degree is equal to h2 divided by x, opposite upon adjacent side. Now tan 30 is 1 by root 3. So we have h2 upon x. So from here we have x is equal to h2 root 3. Right. So here we have x equal to h1 upon root 3 and here we have x equal to h2 root 3. So let's equate them. What will happen? h1 upon root 3 is equal to h2 root 3. So this root 3 goes to the other side and we get h1 is equal to root 3 into root 3 is 3. So it is 3h2. So we have h1 upon h2 equal to 3 upon 1. Okay. So the required ratio is 3:1. Alright. Now let's take up the next question. So this ratio was 3:1. Now let's go to the next question. Now this question says the angle of elevation of the top of a tower at a distance of 120 meters from a point A on the ground is 45 degree. If the angle of elevation of the top of a flagstaff fixed at the top of the tower at A is 60 degree, find the height of the flagstaff. First, we need to understand the diagram properly. Okay, let's say this is the ground. This is the tower. Let's say I'm drawing the tower like this. And on the tower, there is a flagstaff. Right? Alright, so this is the flagstaff and this is the tower. Right? Let's take another thing. It says distance 120 meters from a point A on the ground. Now, from this point A, the angle of elevation of the top of the tower. Right? This is the top of the tower. So this angle of elevation is 45 degree. Okay, and the top of the flagstaff, the angle of elevation is 60 degree. So this total angle is 60 degree. Right, let's give them some names. So let's say BC and D. Please understand that BC is the flagstaff, right, and CD is the tower, and the distance AD is given as 120 meters. Okay, so this distance is 120 meters. Right, now let's take the triangles one by one. What is the question asking? Find the height of the flagstaff. Perfect. So what we have to do is, let's say triangle ADB. Look at the triangle carefully. In the triangle ADB, let's say the height of the tower is H and the height of the flagstaff is X. Alright, so in the triangle ADB, if I take the angle 60 degree, then tan 60 degree will be equal to, the side opposite to 60 degree is BD and the side adjacent to 60 degree is AD. Now tan 60 is root 3, BD is equal to X plus H and AD is 120. So from here we get X plus H equal to 120 root 3 meters. Let it be like this only. This is our first equation. Now let's consider the triangle ADC. This is A, this is D, this is C. In that triangle, we take angle 45 degree. So we take tan 45 degree. Now the side opposite to 45 degree will be CD. Divide by adjacent to 45 degree is AD. Tan 45 degree is 1, CD is H, AD is 120. Great. So from here we can directly see that H is equal to 120 into 1, that is 120 meter. So if you put the value of H in this first equation, you will get the value of X. Alright. So I put there X plus H is 120 root 3. So we put H equal to 120. We have X plus H equal to 120 root 3. That is X plus 120 equal to 120 root 3. So from here we get X is equal to 120 root 3 minus 120. Take 120 common, it is root 3 minus 1. Root 3 is 1.732, minus 1 will be 0.732. So it is 120 into 0.732. If you multiply, it will come out to be 87.84 meter. Alright. Right. So this is the length of a flagstaff. So answer of the question is this one, that is 87.84 meters. Alright. Now let's take up the next question. It says the angle of elevation of the bottom and top of a flagstaff at the top of a building as seen from a point horizontal distance from 10 meter from the foot of the building are 30 degree, 45 degree. Exactly the same question, perhaps the angles are different, 30 and 45. In previous question it was 60 and 45. Let's see. So once again, we take a point on the ground, we take a tower, or let's say building in this case, and there is a flagstaff. From the point, the bottom of the flagstaff and the top of the flagstaff, the angles are, obviously the larger angle is 45 degree. So this angle is 45 degree and the smaller angle is 30 degree, right? Let's again give them some names. So this is A, B, C, D, right? This distance AB is given 10 meters. Let's assume this tower height is H and the flag height is X. So straight away, let's take it like this: triangle ABD. In the triangle ABD, we have tan 45 degree because the angle is 45 degree, right? So tan 45 degree will be equal to DB, opposite side, divided by adjacent side, that is AB. Tan 45 degree is 1, so it is 1 equal to DB is X plus H divided by BA, or AB is 10. So we have X plus H equal to 10. This is one equation. Now let's take the another triangle, that is triangle ABC. Look at the triangle carefully. It is ABC. In that we have angle 30 degree. So tan 30 degree will be equal to, it will be BC, that is opposite side to 30, divided by adjacent side, that is AB. Now BC is equal to H and AB is equal to 10, and tan 30 is equal to 1 by root 3. So from here we can directly see that H is equal to 10 by root 3 meters. So we have the value of H equal to 10 by root 3 and X plus H equal to 10. So if you put it in this equation, you will get X plus 10 by root 3 is equal to 10. So we have X equal to 10 minus 10 by root 3. So what you can do is you can simplify, take LCM as root 3, take 10 common and root 3 minus 1. Multiply by root 3 in numerator and denominator. It will give us 3 minus root 3. So what we have done is we have multiplied by root 3 in numerator, and denominator root 3 into root 3 will become 3. So it is 10 into, now root 3 is 1.732. 3 minus 1.732 will become 1.268 and divide by 3. So it is 12.68 divided by 3. If you divide, it will give us 4.226 meters. Right? So approximate value is 4.226 meters. So height of the flagstaff. Now let's go to the next question. Now this question says the angle of elevation of the top of a tower from a boat moving at a speed 6 root 3 meter per second changes from 30 degree to 60 degree in 2 minutes. Find the height of the tower. Alright. So let's say this is the water level on which the boat is moving from one point to the other point, and the height of the tower is, let's say, H. Okay. And from one point the angle must be 30 degree and later on 60 degree, right? So initially it should be far, because if it is far then only the angle can be smaller, because when it keeps getting closer the angle will keep increasing, right? So this angle is 30 degree, this angle is 60 degree, right? Now you see this distance is the distance traveled corresponding to 2 minutes, right? Now speed is given is 6 root 3 meter per second. So this distance, let's give it some name, A, B, C, D. So that CD distance will be equal to speed into time. Speed is 6 root 3 meter per second into the time is 2 minutes. Now 2 minutes is 120 seconds. Now 6 root 3 into 120 is 720 root 3 meters. Right? Let it be. Now let's assume this BC length is X. Now look at triangle ABC. In that triangle we have tan 60 degree, that is equal to, opposite to 60 it is H and adjacent to 60 it is X. Tan 60 is root 3. So we have H by X equal to root 3. So from here we get H is equal to X root 3. Let it be. Alright. Now look at the triangle ABD. Right? This is ABD. Now in this triangle we have tan 30 degree equal to, now the side opposite to 30 degree is AB, that is H, alright, and divide by BD. Let's write it as BD first. Now tan 30 degree is 1 by root 3. So 1 by root 3 is equal to H by BD. So from here we have BD is equal to H root 3. Right? Now what is BD? BD is equal to, let's use this space. Now BD we have calculated H root 3. Look at this BD. BD is equal to X plus CD, and CD is 720 root 3 meter we have just now calculated here. Right? This is CD. So X plus 720 root 3. And here one more thing. This BD is H root 3. Now this is actually H we have calculated as X root 3. So it is X root 3 into root 3, which is 3X. Wow. So BD is 3X. It is equal to X plus 720 root 3. So we have 3X minus X, that is 2X, equal to 720 root 3. This gives us X equal to 360 root 3 meters. Right? And you can go back and you can calculate H from here. So we have H equal to X root 3, which is equal to X itself is 360 root 3. So it is 360 root 3 into one more root 3. So we have finally root 3 into root 3 is 3. So it is 360 into 3, which is 1080 meters. Right? You have to be a little careful in this calculation. H height is equal to 1080 meters. Right? So this is the answer of this question. Okay. Now let's go to the next one. Now this question says a 20 feet tall, okay. Don't worry, if it is given 20 feet tall man, you have to take it. So whether it is practically possible or not, don't worry about it. Is standing on the bank of a river, he finds that the angle of elevation of a bird in the sky is 45 degree. At the same instant, he observed that the angle of depression of image of bird in the river water, right? So we have to take the bird and the image at the same time is 60 degree. Find the height of the bird from water surface. Water surface behaves as a plane mirror. This is a very important concept. Now why? Because if you have seen plane mirror, I mean you see it every day, right? When you start from your house, you see it every day. So if I keep an object here, right, if this, let's say 1 is the object, the image will be exactly at the same distance on the other side. Okay, so the image will be exactly on the other side. So whatever, the main thing is, whatever is this distance, so if this distance is x, then this distance also should be x. So this is the image. So image is exactly at the same distance from the mirror as the object is. Okay, this is a very important concept in this. Okay, now how is it applicable in this question? Let's see. Say this is the river. The man who is 20 feet tall is standing here, and there is a bird in the sky. This is the water surface. So let's say the height of the bird from water surface is h, right? Let's say B is the bird. Now the image of the bird will be here. Let's say I is the image. But the man can see only from his eyes, not from his foot or any other part of the body. So this is the horizontal line. Man has to see from the eyes only. So angle of elevation of the bird in the sky, this angle is 45 degree. And at the same instant, from the same eyes, the angle of depression of image of the bird will be this angle, and that is 60 degree. This is where a lot of people make mistake, right? You have to see, this is the eye, because see, eye of a man has to be at the top of the body, right? So from there only he can see. Okay, so if this is 20 feet, then in this rectangle, this will also be 20 feet. Then this upper part will be h minus 20. The lower part has to be h because this is the water surface, this is the mirror, this behaves as the mirror. So distance of the object from the mirror and distance of the image from the mirror has to be same. So if this height is h, this length should also be h. Now let's give them some names. Say the man is AP, right? The height of the bird from water surface is BQ. This point is R and the image is I. So look at the triangle ARB. Try to find it where it is. This is A, this is R, and this is B. In the triangle, angle is 45 degree. Okay. So let's say the distance between the man and the bird, let's say it is X. So this is also X. So in the triangle ARB, tan 45 degree will be equal to BR upon RB, RA, right? Now tan 45 degree is 1, BR is H minus 20, RA is X. So we have X is equal to H minus 20. Let it be. Now comes the important part. Look at the triangle ARI. This is A, this is R, and this is I. So look at this triangle. This angle is 60 degree. In that triangle, tan 60 degree will be equal to, the opposite side to this 60 degree is RI. Okay. And the adjacent side is AR or RA. From here we get tan 60 degree is root 3. RI, look at this carefully. RI is RQ 20 plus QI, that is H. So it is H plus 20 divided by RA. We have already calculated RA is X. X is, this is RA. That is H minus 20. Alright, so we just cross multiply. We just solve this to find the value of H, cross multiply. So from here we can see that H root 3 minus 20 root 3 is equal to H plus 20. So bring this H on the left hand side and 20 root 3 on the right hand side. So we have H root 3 minus H will become H common root 3 minus 1. This 20 root 3 goes to the other side and gets added. So we get 20 into root 3 plus 1. So from here we get H equal to 20 into root 3 plus 1 upon root 3 minus 1. Right? So let's do one thing. Rationalize it. Multiply by root 3 plus 1 in numerator and denominator. In numerator we will have 20 into root 3 plus 1 whole square, and in denominator we have 3 minus 1. Now 3 minus 1 is 2. 2 divides 20 10 times, and root 3 plus 1 whole square will be 3 plus 1 4 plus 2 root 3 into 1, so 2 root 3. Right? So if you simplify, root 3 is 1.732 and 2 into 1.732 will be 3.464 and plus 4 will be 7.464 and 10 into 7.464 will be 74.64 feet. Right? So the answer of this question is 74.64 feet. Okay. Now let's go to the next question. Now let's take up this last question. It says a man starts climbing towards the top of the mountain on an incline of 30 degrees from a point on the ground from where the angle of elevation of the top of mountain is 45 degrees. Now this is a very tricky statement. It says there's a mountain, there's a ground, and man starts climbing at an incline of 30 degrees, whereas from that point the angle of elevation of the top of the mountain is 45 degrees. So what we can also see here, that the actual mountain is 30 degree, my actual incline of the mountain is 30 degree at that point. Let's say this point is A, and the angle of elevation of the top of the mountain is 45 degree. This is what it means. After traveling 1 kilometer, suppose he has traveled 1 kilometer to this point. From this point, so suppose this is the horizontal line, and when he looks up, this angle is 60 degree. The new angle of elevation is 60 degree. Alright. Find the height of mountain. Perfect. So this distance is 1 kilometer. Okay. This height is H. From this point drop a perpendicular. So this will become a rectangle. Let's give some names. So A, B, C, D, E and F. Okay. Now there are many ways of doing this question. First, look at the triangle ADE. Right. In that triangle, you have this angle 30 degree and this hypotenuse given as 1 kilometer. So what we can do in this question is, we can take this as sine 30 degree. Now sine 30 degree will be 30 opposite side, that is ED, divide by hypotenuse, that is 1 kilometer. Now sine 30 is 1 by 2. So we have ED equal to 1 by 2 kilometers. Perfect. Similarly, you can use cos 30 degree. Cos 30 degree will be equal to, look at 30 degree and cos will be adjacent side, so AD, divide by hypotenuse, that is 1 kilometer, and cos 30 degree is root 3 by 2. So clearly AD is equal to root 3 by 2 kilometers. Very good. Now what do we have here? Look at this carefully. This length we have calculated 1 by 2. So this also has to be 1 by 2. This length we have calculated to be root 3 by 2. Now one more thing, look at the triangle ABC. In the triangle ABC, the angle CAB is 45 degree, this total angle is 45 degree. So we can say tan 45 degree is equal to CB upon BA. Now tan 45 degree is 1, CB is equal to H. So what do we have? So we have BA is equal to H. Alright, so this total length is H. This AB length is H. Out of that, this is root 3. AD is root 3. So DB will be, this one will be equal to H minus root 3 by 2. Right? So if this is H minus root 3 by 2, look at the distance EF very carefully. EF will be equal to DB and will be equal to H minus root 3 by 2. So I am writing in small H minus root 3 by 2. Look at the upper part, that is CF. What is CF? Total CB is H, FB is 1 by 2, so CF will be H minus 1 by 2. Right? You have to be really careful in this. Why? Because now what we will do is we will use triangle EFC. In that triangle, the angle is 60 degree, so we say tan 60 degree will be equal to side opposite to 60 degree will be CF and adjacent to 60 degree will be EF. Now tan 60 degree is root 3, CF is H minus 1 by 2, alright, and EF we have calculated it is H minus root 3 by 2. So if you cross multiply, you will get root 3 into H is H root 3 minus root 3 into root 3 by 2 is 3 by 2 and everything is equal to the other side H minus 1 by 2. So bring this H on the left hand side, so it will give us H root 3 minus H, so H common, root 3 minus 1 will be equal to, this 3 by 2 goes to the other side, so plus 3 by 2 minus 1 by 2 which is 1, right. So H is equal to 1 upon root 3 minus 1 kilometers. Okay, you can simplify by multiplication of root 3 plus 1 and division of root 3 plus 1, which will give us finally root 3 plus 1 by 2. If you simplify, you will get root 3 plus 1 by 2. So the height required is root 3 plus 1 by 2 kilometers. Alright. Now this question is a very special question. There is another method of doing the same question. So I'll repeat the whole process but in a new method altogether. Look at this closely. So we'll again start from the very beginning, right? I'll say it is method 2. And this is a very simple method for this particular question. Alright. How does it happen? Let's see. So this is the ground. This is the mountain. The angle of elevation from this point is 45 degree. So first of all, if this height is H, this width will also be H. Alright. Because this 45, 45, 90 degree triangle. Now this incline is 30 degree. Okay. And from this point, this incline is 60 degree. Now see, this is a very interesting situation. If this total angle is 45, this is 30, then this angle has to be 15 degree. Similarly, if this is 60 degree, this is 30 degree, and this total again has to be 45 degree. Why? Because these two angles has to be equal. Now, so this particular angle will be again 50 degree. So if I give some name, let's say this is A, B, C, and D, E, F. Now look at the triangle AEC. In the triangle AEC, you can see that this angle is 15 degree, this angle is also 15 degree. So side AE will be equal to side EC. And we already have A equal to 1 kilometer, so EC also 1 kilometer. Right? This is very interesting. This is 1 kilometer. So this length EC will also be 1 kilometer. Now what I'll do, I'll just draw triangle ADE separately. Look at this ADE carefully. What do we have here? This is 90 degree. This angle is 30 degree. And this is 1 kilometer. And we know the ratio of the sides in 30, 60. See, this is 90, this is 30. So this has to be 60. Right? So this side, ED, will be equal to, opposite 30 will be half of the hypotenuse. So directly 1 by 2 kilometers. So the ratio has to be 1 is to root 3 is to 2. Remember, 1 is to root 3 is to 2. Here for 2 it is given 1. So for 1 it will be 1 by 2 kilometer. So ED is 1 by 2. So FB will also be 1 by 2 kilometer. Now I'm going to draw a triangle EFC. Look at that closely. Triangle EFC is a tall triangle. But not to forget, this angle is 60 degree. This is anyways 90, so this has to be 30. This is EFC. We have already seen that EC is also 1 kilometer. So here also the hypotenuse is 1 kilometer. Right? And remember the side ratio, opposite 30 it has to be 1. Opposite 60 it has to be root 3. And this has to be 2. So 2 is 1 kilometer. So 1 will be 1 by 2 kilometer. So this root 3 will be root 3 into 1 by 2. So directly it is root 3 by 2 kilometers. Which one? CF. So we get the length of CF as root 3 by 2. That is CF root 3 by 2. And from there you can very clearly see that the mountain height is actually CB. Now CB is CF plus FB. CF is root 3 by 2. FB is 1 by 2. Eventually in denominator 2 and in numerator root 3 plus 1. So the answer to this question is root 3 plus 1 by 2 kilometers. So this is what we have already done. If it is necessary, you can put the value of root 3 as 1.732. So it will be 2.732 upon 2. And if you divide, it is 1.366 kilometers. Right? So be careful about the unit and the value. Right? So here we have completed the chapter called height and distance with a little bit of theory and all types of practice questions. Alright, so you can solve the exercises given in the book, the class exercises. If you have any problem, you can always get back to us. Thank you so much. God bless you. Take care.